So we looked at the way that Apache does it with OpenSSL, and it turns out that they store the bare encoded sort of the whole key bit without the rest of the package, just the bare encoded key. And so we're looking for that. I don't know about other applications that use RSA keys. We haven't looked at it. You should look at it. But if you want to make sure that you're not susceptible to exactly what we're doing, just break up the information in some way that's harder than it already is. So don't use that encoding. Yeah, break it up. I mean, security through obscurity isn't a good idea, but it's better than what you're already doing. That's it. So.
Does that answer your question, Paul? Sort of. Okay. We can talk about it later, if you want. We have a couple other people. Yeah?
Hello. I confess I don't actually know a great deal about RAM hardware, but if I have to, what I understand about this is that the reason you have these cold boot attacks is basically that the caps in DRAM drain slowly. So would it be possible to fix this, or at least help mitigate it in hardware, if you, when RAM was powered, you held open some transistors, and as soon as RAM lost power, you allowed those to close so that all of your capacitors were shorted together. So basically you try to pull all of RAM down to a common value that's the average of all of the bits in this huge sea of bits, right? 512 megabytes worth per stick or something like that.
So there are a couple of memory vendors that have talked with other people, but not directly with me. I don't think, not with the other people on our team either. And they have a market for this. There are people that do care about this attack, and so it is a possibility that some of the people that are involved with that particular area of hardware design will come up with a solution where they'll have a chip that costs N number of dollars more, and it has this particular physical memory retention phenomenon. I don't think, though, that we'll be able to do that off the bat. Someone suggested making sort of like a RAM condom, like a microcontroller and a slot. And basically, when the intrusion detection system on the case goes off, it sends both a software event and a hardware event. And the hardware event would basically write to memory. I think that might be a cool idea. And if someone that was pretty skilled with hardware wanted to build it, Phil Cherone, if he's here, probably be something useful. But I think it's limited. Again, if you have a one-off, I think you could maybe pull it off. I think if you have like a standard solution, you just change the attack surface. It's just several steps you take before you do it. And again, it would also require power and various other things that might be kind of hokey.
Well, so there was an interesting trick in the days of the VAX where if you lost power, the architecture definition required that you keep the disks and memory and everything up and running for 300 milliseconds. The way this was achieved was actually to turn the big spinning platters of disks into generators to power the machine. So
that's awesome.
But the whole point here is that you have a bunch of ones stored in caps, right? You have power on the chip. Mm-hmm. So perhaps you could draw that off to help flatten the contents of the chip.
It's possible. I think that's something that would be worth looking into. I mean, maybe you'd be interested in checking out the code and finding out if you can actually change the memory retention phenomenon. So, thank you.
Thank you.
So, first of all, thanks a lot for Tor. Really appreciate that. Glad you guys
have free Tor stickers too, by the way, if anybody wants some.
I'm very glad when I'm in an airport and I have to buy something that I've got things like that to all those evil hackers out there. In addition to that fact, I was reading recently about a Tor Live CD that claimed that when it shut down, it wiped the memory. What about something like that? I mean, I realize it doesn't remove all of the possibilities for memory remnants attack, but a lot of us are a little more concerned with, we get off the plane, we have to go through customs, they're going to confiscate my laptop. It'd be nice if when I shut it down, it wiped the encryption key from memory. I mean, is that practical?
So, yes and no, I guess. Depends what Tor Live CD you're talking about. Do you know which one it is?
It's been a little while.
Okay. It's possible that there's a Tor Live CD that does that correctly. I would say look at the source code, verify it, find out who produces it, whether or not they're trustworthy, whether or not they're good. I don't know which particular one. There's a lot of stuff that uses Tor.
But the ideas sound, at least, it would help for those of us that have that particular problem.
Well, so the interesting thing about this is that in the particular case of Tor and in the case of a live CD, there are a couple of different issues that you really have to face. One of them is Peter Gutmann's memory residue issue. Basically, you're oxidizing the DRAM cells in a particular way. So I don't know if that particularly protects it because you're not overwriting the memory a number of times. You're not like changing the pattern that's by default stored in that chip. For someone who's just trying to reboot the machine, like let's say you're in an internet cafe and someone wrote a tool so that whenever someone logged off the computer, it automatically rebooted and like grabbed the memory, I don't know, to detect memory faults or something. It seems to me that probably it would protect against that threat if it was allowed to get into the shutdown routine. Obviously, if you can't get to the shutdown routine, like if you're a server, that doesn't really help. So it won't help against seizures, but it might help against a particular adversary of a person who is going to come to the machine when you're done and you've been able to take proactive measures. So.
The other question I had for you.
Yeah, I'm going to.
I actually had a chance to try out the COM32 version that stomped over most of the low memory, but I did find that it was pretty cool, but while I was going through and testing it and trying to figure out how to make it work, I actually had the laptop I was using to test off for probably close to 10 minutes. And while most of the memory came back as complete and utter garbage, I did pull a user agent string of IE7 out of it. Have you ever had something like that? I mean, that is a really long time to pull something valuable out.
Yeah, yes, basically, yeah. I mean, older ThinkPads have much longer data retention times than newer ThinkPads, which are almost non-existent. Yeah, I mean, it's interesting. I'd like to see a full map of all of the different memory and whether or not, by default in the board that it's in, how it behaves. I think that would be really useful, and it's a really big problem to try to map all of the memory that's in use by all of the people in the audience without their participation. So if people want to help with that, it would be really useful. It'd be really hard to do it without their participation. So, thanks.
Just briefly, I know most of the discussion so far is centered around the PC architecture and variants thereof, but has any discussion or any of the scope of your research involved interaction of any of the embedded systems, is specifically security related, like in the case of smart cards, or in my case, like the USB crypto token involved, not necessarily with the storage of the private key, but any time that you'd have to deal with a session key being generated, that any dynamic refreshing has to be done on from the teeny little device here to the computer itself, and sniffing any of that.
So we didn't particularly work on that, although, so Bill's day job is working on VxWorks. So, I mean, one of the things that he talks about on a regular basis when it comes to DRAM revenants is that, you have to scrub the memory, even on embedded systems. I mean, this phenomenon is something that is, it's an electrical phenomenon of memory. So it's not limited to x86. It's just that our tools are limited to x86. And as far as smart cards, I mean, a smart card is only as strong as, I guess, Chris from FlyLogic, whether or not he's attacked it. I wouldn't trust anything like that he has successful attacked, because he beats everything pretty much that he tries. And most hardware also has weird debug pads and backdoors, Sure. So, like, can I talk about the SLE thing? Yeah, okay. So, do you guys remember the Kinko's card? So there's a. I'm sorry to ruin this for anyone that cares. That chip is the best chip in the whole world. Basically, there's a specific debug pad that has a single gate preventing it from telling you the secret 24-bit code that prevents you from doing things to the card. And all you have to do is know where the debug pad is, and then you can get the 24-bit code when you power the card on. So smart cards? Not so smart, maybe.
Just a last statement. Would it be safe to say that...
which he can probably follow up on that even more.
Yeah, I wanted to add that unlike computers, most smart card readers do have secure key storage. So the crypto coprocessor is reality in most smart card applications and relies on some secret, obscure algorithm to encrypt keys.
Well,
so that would be a nice reverse engineering target for future work. But those are so far believed to be very secure.
Well, who could possibly reverse engineer some proprietary secret hardware, Karsten? maybe you did that already.
You mentioned earlier ECC memory, and you quickly went over it, saying that basically it was also vulnerable, but that some chipsets were actually wiping it and all that. And I was wondering if you could elaborate on whether ECC memory is totally vulnerable or whether or not it is.
Well, okay, so actually I think ECC memory is a special case for a number of reasons, because it makes people feel secure when they're not, and it does some things that at certain times will be useful to a user who cares about the confidentiality of their memory. But basically, when it comes down to it, ECC memory, if it apply, like the way that Intel has they have an embedded programming specification that I have on my shelf, and basically what it says is that when you power on the chip, the first thing you should do is scrub the chips, because there's going to be all sorts of bits in all sorts of different states, mostly on and off. And essentially, if you are using ECC memory, what that means to you is if you have a controller that does that, then your controller is going to take care of that, or perhaps your BIOS will take care of scrubbing that as well. But what's really bad, in my opinion, though, is that it seems possible to me that you can use the error correcting of both the code that we've published and also the fact that it's ECC memory and can correct errors for you in hardware. So if you were to not scrub the controller and then apply that error correction that's in hardware, and then also you wanted to apply the AES fixing, it seems like you could get more bits. But since we are not really seeing a lot of data loss, it just means that you might feel a little bit secure at some times. So yeah, does that answer your question? All right, cool. Anybody else? Yeah? That you can't read.
Is it possible to use any of these on, say, a PlayStation 3?
A
You can run Linux on it, and
like, so you want to analyze the memory of the game that you're writing?
no, basically, I'm thinking about a different architecture because 128 bits versus 64 bits versus 32 bits RAM.
I mean,
and if they use something special, different.
so if you have just memory chips in whatever game console you're looking at and it's electrically compatible with a particular BIOS, there's no reason that you shouldn't be able to swap it out. Whether or not that data will be meaningful to you, I guess, depends on if you understand what it's doing. But I think that you should probably be able to modify this so that you can, I mean, Linux PlayStation, right? It should be possible to set it up to boot in some way over the network, and you can see yourself. You can also just reboot a PlayStation running Linux and see if the memory persists. It's possible that they don't scrub the memory when they reboot, and if that's the case, let us know. It would be kind of cool to find out that there's a game system that has this phenomenon. So, thank you. So, I think that's it. Thank you very much.